This video will be going over section 9.7, which is on matrix inverses. The main topics in here, the first one is to talk about what the identity matrix is. That's going to be very fundamental when we move on to actually finding the inverse of a matrix. And then we'll relate this to linear systems, because that's really the point of this chapter. Every linear system of equations can be written as a matrix equation. This will be very different from an augmented matrix, as I will point out. And then the last thing, when you have a matrix equation and you solve a matrix equation, you end up having to compute the inverse of a matrix. All right, so the first thing we're going to talk about the identity matrix. The identity matrix is a special matrix that is given its name basically because it's like the number 1. If you multiply a matrix by an identity matrix, it doesn't change it. Right. So the n by n identity matrix, often labeled as I with a subscript n to indicate the number of rows or columns, or just I if it's understood how many rows or columns you have, is the matrix which has an entry of 0 if the row and column number are different, and 1 if the row and column number are the same. Now, because we won't be going larger than a 3 by 3 matrix, we can write the 2 down. The 2 by 2 identity matrix is right here. These two entries, 1, this is in row 1 and column 1. This is in row 2 and column 2. So those are 1, and all the rest of the entries are 0. For the 3 by 3 identity matrix, it just really starts to fill out and looks like putting a 1 down this diagonal starting at the top left, and then zeros everywhere. But this is row 1, column 1. This is row 2, column 2. This is row 3, column 3. They all get 1s. Every single other entry here has a different row and column number. That's why they're zeros. Okay, so one thing I have highlighted here, this isn't something you necessarily need to write down. I just wanted to read it. But what you notice in the last section on matrix algebra is we didn't talk about division of matrices because you can't actually ever divide by a matrix. The inverse matrix is our quote-unquote replacement for division, but it can only be done in specific situations. Inverse matrices can only be computed for an n by n matrix, so a square matrix, when the determinant of that matrix is not 0. Now don't worry, the method we go through and do it, you don't actually check the determinant. It's just sometimes you may run into the case where you can't compute the inverse. And if that happens, that means that determinant is actually 0 and there is no inverse. It's sort of like you can't divide by 0. Since it's our replacement of 0, you can't divide by 0. The determinant's almost taking the place of that. But we'll look at some examples which works, and then I'll briefly outline why it might not be possible to figure out. Like with solving systems of equations with row operations, you can let the calculator do that work for you, but you need to know how to properly set everything up, read off your solution, and everything with that. All right, so I will show you how to do this in the calculator. It's going to be based on doing RREF in the calculator. Right, but you have to know how to set it up. The calculator doesn't have an inverse button. So for the following matrices, compute their inverse. And I have here, the method displayed below is how you use the calculator. To compute the inverse, you augment the given matrix on the left with the identity matrix on the right. So what we're saying here, just to outline that, we start by taking our matrix here, A. I'm going to rewrite it, -7, 2, 3, and -1. Augmenting just means you stick something on the side of it. We really like to visualize separating it by putting a bar. And over here on the right side, we put the identity matrix. Since this is a 2 by 2 matrix, we put the 2 by 2 identity matrix over here. It's 1, 0, 0, 1. Okay. So this is our setup. If you do not do this step, then you can't plug the correct thing into the calculator, and therefore it won't be able to do the inverse. Right, so what happens here, once we set it up, the goal, what's going to happen is if we press, or if we go through and row reduce on our calculator, I'm going to go ahead and do that. You got to set it up, because we've seen how to row reduce on the calculator. Now we're going to do it with this bigger matrix. All right, so open the calculator. We're going to go to the matrix menu. Now the matrix we are doing is a 2x4 matrix. Right? Remember, with augmented matrix, you don't actually do a bar here, just one fluid matrix. So it's 2x4. And it's going to go across the row, so be careful about typing it in, don't mess up. The first row is -7, 2, 1, and 0. And then the second row is 3, -1, 0, and 1. All right, and that is the matrix we have set up. We have our matrix A on the left, the matrix I on the right. So go ahead and quit this. And now we're going to reduce to row echelon form, RREF. The goal here, which your calculator is going to do the steps for you, but the goal here is to use row operations to get this side into the identity matrix. Basically, we want to do row operations to make a 1 here, a 0 here, a 0 here, and a 1 here. What I want to go ahead and mention now is your calculator, if it can, will do this. If your calculator cannot reduce this side to the identity matrix, then that means there are no inverse. So if the calculator cannot get this side into the identity matrix, then there is no inverse. All right, and what you would have to put is D and E. All right, but let's go ahead and RREF this thing. So go to our calculator, hit the matrix menu. RREF is under the math menu. It's down quite a bit. Make sure you do RREF. And the matrix I made my 2x4 is matrix A. Make sure you use the right one. And I'm going to go ahead and write down what we got here. So our first row is 1, 0, -1, -2. I'm going to separate it like we had before. And the second row is 0, 1, -3, -7. Right? Now the hope is, like we outlined here, if this side becomes I, which it is, right, this is the identity matrix. It looks exactly like this, 1, 0, 0, 1. Then the right side of our bar is the inverse. Okay, so this is the inverse matrix. And I don't think we wrote it above. Did I write it above? No. Okay, so the notation for the inverse matrix is like writing notation writing an exponent of -1 on your matrix. So a to the -1 power is right here. But what you want to make sure you do is you separate it out like this. And so you would want to point this out. This is the notation for the inverse. Make sure you use the correct letter. Since we have the matrix A here, A inverse is the -1 power. It has nothing to do with being 1 over A. One thing I can at least relate, if you remember doing inverse of functions in college algebra, you use the -1 power on f of x. So same idea here. All right, but that's what we're gonna do to figure out inverses. All right, we just want a way to do this. There are formulas for it, which some of the videos on homework have, and you're welcome to do that as well. You just need to be able to get the inverse one way that is correct. I will caution you about using those formulas. Is if you miss one part, the formula is very short, and if you miss one part, it throws off the whole answer. There's not really much credit to give you. All right, but same thing here. If we want to figure out the inverse of matrix B, we join matrix B 1, 4, 4, 2 with the identity matrix. And then we RREF in the calculator. Okay, so we got to set this up. Our matrix B is B and I are a 2 by 4 matrix. So we go over to our calculator. 2 by 4 again. The first row is 1, 4, 1, 0. And those are already, this side's already gonna be done for us because it's the same as last time. The second row is 4, 2, 0, 1. Okay, so we got that filled out. 1, 4, 1, 0, 4, 2, 0, 1. Quit. Go to our matrix menu. Go down to RREF in the math menu. And use matrix A again. That's what we called it. Call it whichever one you want. Just make sure you use the correct one. And this is one of the things that can be a little troublesome, right, as you get fractions. So I'm gonna first start by just writing down roughly what it is, and then then I'll talk about the fraction thing. All right, so we got 1, 0, 0, 1 on this side, which means since we got the identity, what's over here is actually the inverse. Okay, and we got, I'm gonna write down a few decimal points and then talk about this. We got negative 0.143. Now all these are actually fractions, and you're gonna have to give the fraction. 0.286. 0.286. And negative 0.071. Right, so we got that written down. I just want to add in here, I'm writing this down to show you how to fix this. You won't even actually write this step down when you do it yourself. These are rounded decimals, and we need fractions. Right, you do not want to say the inverse is this matrix here. You want the fractions. All right, so all you have to do, you know how to switch from decimal to fraction in your calculator, and you actually do it the same exact way. All right, so let me go write that, switch to fractions in the calculator. 1 0 0 1. This is an issue. When we hit go to that from decimal to fraction, you hit the math and the fraction button, and you might be surprised, but it actually does turn all those entries into fractions. So our top left one is -1/7. Then we got 2/7 and 2/7. And then the last one is -1/14. Okay. Those of you that use the formula that, at this point, I don't think I would recommend it just because, this isn't too bad. But you'll see where the denominator of that formula comes from. It's related to the determinant of the matrix, which here is 2 minus 16 is -14. Okay, but this is what you want to type in for your for your inverse. You do not want to use the decimals. So -1/7, 2/7, 2/7, -1/14. Right. Now, if you use the online calculator that I've been doing all the matrix stuff with, if you hit the inverse matrix, this is something else. We won't really use this inverse matrix method button. I just realized that there's a Cramer's rule button on here, but you don't want to use that either for the other section, right? So inverse matrices only count if they are only exist if you're talking about a square matrix. So it's gonna have only one thing here. If you have a 2x2 matrix, you want to do matrix dimension 2. And if we want to do the inverse of our matrix B here, we would type in 1 4 4 2. And it just gives that to you right away. You don't have to set up anything, but I think one thing that's a little unsatisfying about this is you didn't do anything. The calculation it goes through is actually what you do. You write the augmented matrix, you row reduce it, make the identity matrix over here, and then this side becomes your inverse. All right, now I will absolutely say, when you do the inverse, when you have to show me your work, just writing B inverse equals this is not valid. You got to at least plug it in to the augmented matrix and show me what it becomes. So I know you know how to set it up. All right, but that is the inverse. We can also do a 3x3 inverse just as easily. Okay, so matrix C here, we have the matrix 1, -2, 3, -2, 5, -4, 0, 0, 1. Doesn't matter what the size of the matrix is, as long as it's a square matrix, you can talk about doing the inverse. And when we attach it with the identity matrix, since this is a 3x3 matrix, we got to put the 3x3 identity matrix over here. So we got 1 0 0 0 1 0 0 0 1. Right, but once you do that, set it up. Right, make sure you set it up. Then let your calculator, let that online calculator do the work for you. I'll just do this one with the online calculator. Actually, I'll do it with the regular calculator so you can see it done again. We'll go back to the matrix. This is a 3x6 matrix. It has 3 rows, but it has 6 columns. The first row is 1, -2, 3, 1, 0, 0. We got 1, -2, 3, 1, 0, 0. That's a very big matrix, so you can't even see all the columns at once. Make sure you're careful in typing it in. The second row is -2, 5, -4, 0, 1, 0. We got -2, 5, -4, 0, 1, 0. And then the last row is 0, 0, 1, 0, 0, 1. 0, 0, 1, 0, 0, 1. All right, you can go double check that you did everything right. We got the identity matrix on this side, so that side's correct. You double check this is our matrix C that we called. So we quit. Then same thing. Matrix, go down to the math menu, go down to RREF, and we want to put the matrix that we wrote it in as, which is matrix A again. And if you end up with messy decimals, remember, switch to a fraction the way we did it. But this one, we do get the identity matrix on the left side. Which means the right side becomes is in fact the inverse. 5, 2, negative 7. 2, 1, negative 2. And 0, 0, 1. All right, so C inverse is over here. 5, 2, 0, first column. 2, 1, 0, second column. Negative 7, negative 2, 1, third column. Right, so that's how you actually compute the inverse. Another thing we could do, as far as this kind of topic, testing you on this topic, is maybe not saying compute this inverse, but ask the question: is this matrix the inverse of this other matrix? So we give you 2, and you tell us that. And the way you check is by multiplying. Right, so one way to check that you computed the inverse correctly is by multiplication. Specifically, if you multiply a matrix by its inverse, it should give you the identity matrix. And the only time this is valid, if you switch the order, the inverse times A, it's still the identity matrix. All right, so we're going to do it with B and B inverse. We figured, this is the one with fractions. There's no reason to be afraid of fractions. All right, so I'm going to first just write down what B and B inverse were. B was the matrix 1, 4, 4, 2. B inverse is the matrix negative 1/7, 2/7, 2/7, and negative 1/14. Wait, that's just positive 2/7. All right, and we want to multiply them in both orders. B times B inverse and B inverse times B. Remember, in general, these can be different. All right, so we've got B on the left, B inverse on the right for this one. Now, we did do this in the calculator. Our calculator better not be wrong, or there's some serious issues. But it might be the case that you're just given these two and you want to compute the inverse. And yes, you do have to do it like this, not just check it in your calculator. If you multiply these out, you'll be able to multiply these. The two middle numbers check out. They're the same. And the two outside numbers tell us the result is 2 by 2. So let's see if this ends up being the identity matrix. All right, so first row, first column entry, we get 1 times negative 1/7 is negative 1/7 plus 4 times 2/7 would be 8/7. entry over here, 1 times 2/7 is 2/7 plus 4 times -1/4 is -4/14. Second row, first column, we go across second row, down the first column. 4 times -1/7 is -4/7 plus 2 times 2/7 is 4/7. And then the last entry here, row 2, column 2, across row 2, down column 2. 4 times 2/7 is 8/7 plus 2 times -1/14 is -2/14. And remember, we want this to be the identity matrix. We want 1, 0, 0, 1. Now we're not going to forge it. We're going to make sure it's actually that. All right, so -1/7 plus 8/7 is 7/7, which is in fact 1. The next one over here, 2/7 plus -4/7. You can simplify this real quickly. Take a 2 out of each. This is the same as 2/7. The 2/7 minus 2/7 is in fact 0. It's looking good. -4/7 plus 4/7 is definitely 0. And then the last one, 8/7 plus -2/14. You can take a 2 out of each of there, and we get 1/7. 8/7 minus 1/7 is 7/7, which is 1. All right, so this would suggest that we're pretty much there. We do have to do it both ways. We have to multiply b on the left, b inverse on the right, and then we have to do it the opposite way. All right, we got to do b inverse on the left and then b on the right. 90% of the time, it's very hard to come up with an example where this works one way and not the other, but it's still necessary to check both ways. All right, so we got b inverse on the left now. And b on the right. Right, the size and everything is the same. We still got 2 by 2 and 2 by 2. So the inside numbers here are both 2. They work out. And the outside numbers tell us the result is going to be a 2 by 2 matrix. Once again, it's a good idea to practice the multiplication anyway, and all the little steps that go into it. All right, so we've got a 2 by 2 result. Do we get 1, 0, 0, 1? That is the question. We want to get that again. So our first row, first column, we go across the first row, down the first column. We got -1/7 times 1 is -1/7. Plus 2/7 times 4 is 8/7. Well, that looks exactly the same. Moving over, we got -1/7 times 4 is -4/7. Plus 2/7 times 2 is 4/7. Moving down, 2/7 times 1 is 2/7. Plus -1/14 plus times 4 is -4/14. And finally, our last entry, 2/7 times 4 is 8/7. Plus -1/14 times 2 is -2/14. And if we go through and simplify this, each one will get the identity matrix again. -1/7 plus 8/7 is 1. This is definitely 0. 2/7 minus 4/14. This is the same thing as 2/7, so we get 0. And lastly, 8/7 minus 2/14. This is the same thing as 1/7. 8/7 minus 1/7 is 1. Okay, but they both work. You have to check both. Right. Right, so the inverse isn't just clicking it in your calculator, setting it up in augmented matrix, it's also checking. Not all the problems you have to check for. You will see some on the homework. All right, so the last thing in this section is the matrix equation for a linear system and how you use the inverse to actually solve. Right. So any linear system can be written as a matrix equation of the form AX equals B, where A is a matrix of the coefficients, so the X, Y, and Z columns, or whatever your letters are. X is the matrix of the variables. Now this can be misleading because X might actually be a variable in your problem, but it is a matrix of the variables. So it's going to look like a one column matrix, which we'll see. And then B, lowercase b, because it's also one column. For whatever reason, if a matrix has one column or one row, we typically represent that with a lowercase letter. B is the matrix of the numbers after the equal sign, so this stuff over here. And these are just the numbers. All right, but once you do one, it's pretty quick. These first two here are just setting up. For the following systems, write them as a matrix equation AX equals B. Right, so we're going to have our matrix A. We're going to have our one column matrix X. It's going to look like that, equals. And then over here, we got our matrix B, which is the column of numbers. Right, so you want to go ahead and fill this out. You know how to fill out each one of these parts. Well, at least the A and the B part. I'll go through it all though. So for the matrix A, you just fill out the X, Y, and Z columns like we did before. The X column, just be careful about missing letters here. We would have 1, -2, and 0. The Y column, we would have 3, we would have 0, and 1. In the Z column, we would have 1, -1, and 4. Now the X column is actually just your variables in this order, in the order of the columns, starting at the top. So the variables we have here are X, Y, and Z. And we start with the top and go to the bottom. All right, so our first one over here is X. We put X. Then our next one here is Y. We put Y. And our last one here is Z. We put Z. And then the numbers we put in order as well. 14, 12, and 3. All right, now the reason this works is if you multiply these out. I'm not going to actually do it because it gets a little messy. But if you multiply these out, think about going across the row and down the column. The first one would give you 1x plus 3y plus 1z, which is exactly this, equals the top number 14. If you go across the second row and down the column, you get -2x plus 0y minus 1z equals 12. And the last one would be 0x plus 1y plus 4z equals 3. So it's a way of taking our equations and writing that as a multiplication. All right, so I just want to do one more here because we get so used to x, y, and z that you always want to write x, y, and z. You can have any letters. They don't even have to be alphabetized, even though these are. You just got to do it in the order it tells you, or the order it's given, rather. So you're going to have A If you look at the variables here, we got R, S, and T. Let's go ahead and fill that out. The R column should be 30, negative 20, and 20. The S column should be 15, 25, and 0. And the T column should be negative 50, 0, and 40. The X column here is our letters in order, R, then S, then T. So it's really helpful if you actually do this when you set it up on your paper, because you can see easily the order to put them in. Right, and then finally the column of numbers. I don't know why I said column twice. We have 140, 120, and 300. Right, so that is how we set up a matrix equation for a system of equations. We're going to do one example where you actually solve it. Right, so I'll leave this second one up here in view while we talk about the next part here. All right, so the inverse comes into play when solving a linear system if it is written in the equation ax equals b, which we have here. All right, the reason for this is if we multiply each side of the equation by a inverse, then what happens is you get x equals a inverse times b. So I don't need you to memorize this at all. Oh, I need you to memorize the formula, but to explain why this works, if we multiply each side of the equation by a inverse, the order of multiplication matters. We want to do it on the left side like this. Then what happens is this stuff right here, when we multiply a times a inverse like we saw last section, and a matrix times its inverse is I, the identity matrix. So if we plug that in, we get I times x equals a inverse times b. And the best way to think about I is what I mentioned at the beginning. It's like the number 1. If you multiply something by the identity matrix, it stays the same. Now, I times x equals just x. So multiply by I doesn't change anything. Okay, once again, you don't have to memorize this, but I wanted to talk about the formula for a second. Where it comes from is not something I made up just out of thin air. So if you go ahead and just replace ix with just x, we get x equals a inverse of b. All right, so if we multiply a inverse times b, then we get our solution x, because remember x is the matrix of our letters. All right, so we're going to go ahead and do that, and you can see the way this question's worded is it's telling you to do it like this. Solve the system of equations by creating a matrix equation. All right, so this is saying make ax equals b, and then using the inverse, we're going to x equals a inverse of b. All right, so let's start by making our equation. Since you only technically need a inverse and b, maybe if you want to jump ahead and just write down what a and b are, that's fine, but I highly recommend just practicing this anyway. So let's make our equation. All right, we're going to have our matrix A here, consisting of x, y, and z in that order as our columns, because that's what we're given. Our x column is 2, negative 1, and 1. Our y column is negative 4, 1, and negative 2. And our z column is 1, negative 1, and 0. our X column, our X matrix is X, Y, and Z in that order. And then this equals the B column, 6, -2, and 3. All right, so what our formula says here is if we figure out A inverse, we need to get A inverse, then we can multiply it on the left of B and we'll have our answer. So we got to get A inverse, and we talked about doing that in the calculator. We join up our matrix 2, -1, 1, -4, 1, -2, 1, -1, 0 with the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, and we row reduce RREF. All right, I'm going to do this on the website this time. I did the other 3x3 inverse on the calculator. So we go to inverse matrix. Our matrix size is 3x3, the one we want to find the inverse of. And the matrix we're finding the inverse of is 2, -4, 1. Then -1, 1, -1. -1, 1, -1. And the last row is 1, -2, 0. And we calculate it. And we get our inverse right here. Right, so we RREF it. We did get an inverse. We'll get the identity matrix on this side, on the right. Oops. 0, 1, 0, 0, 0, 1. And then our inverse first row is -2, -2, 3. The second row is -1, -1, 1. And the third row is 1, 0, -2. All right, and what we got over here is our inverse. Right, and what the formula up here says is X equals A inverse of B. Okay, so X, I'm plugging in what X is because when you multiply A inverse times B, the order of your result matters as far as what X, Y, and Z are. All right, so A inverse, gonna plug in what we got there. -2, -2, 3, -1, -1, 1, 1, 0, and -2. And we multiply by B. Now, once again, remember the order of multiplication matters. If you switch this order around, you won't even be able to multiply it. But this you can multiply. This is a 3x3 matrix. This is a 3x1 matrix. Oops. Okay, so the inside numbers match. And the result is a 3x1 matrix. 3 rows and 1 column. Right. So let's just go ahead. Once we multiply these, we'll get some numbers here and we'll have our answer. So we go across the rows as we go down the 1 column. -2 times 6 is -12. Plus -2 times -2 is 4. Plus 3 times 3 is 9. Row 2 down the column, -1 times 6 is -6. Plus -1 times -2 is +2. Plus 1 times 3 is 3. And then across row 3 down the column, 1 times 6 is 6. Plus 0 times -2 is 0. Plus -2 times 3 is -6. And if you simplify each one of these numbers, the top one we get 1, the middle one we get -1, and the bottom one we get 0. Right, so the reason why it's so important to write this part in order is now the numbers correspond. The top number is x, the middle number is y, the bottom number is z. Okay, so we get x equals 1, y equals -1, z equals 0. Right, whatever order your problem's given in when you make your equation, you have to make sure you write the variables in that order. If they're not alphabetized, if they're random letters, that's going to affect if you don't actually do this part. You got to make sure you write this down. But we got our answer right here. Right? And that is how you would solve a system of equation using the inverse. You can even go through and check your answer if you want. But that's it.